afternoon, all of you. My name is Syed, Abdur. I'd like to start the topic with DFIG induction generator for constant power control and faults. Basically, in this research paper, what I did is I have identified the fault and how to control the faults and how to introduce new faults in this particular system. That is nothing but DFIG, DFIG. What do you mean with the term W? Means we are supplying two sources. By using two sources given to one single machine, and we are operating and then we are calculating its fault analysis. Generator, as we know that it takes the mechanical energy as an input and gives out the electrical energy as the output. So these are the contents which we will go and discuss. So nowadays, wind energy has become a viable solution for any kind of a power problems. So in addition to other renewable energy sources, one way for generating electricity is from the energy resources to wind turbines. That is that they can convert the energy contained in the flowing air into electricity. So with the increased penetration of the wind power into electrical grids, DFIG wind turbines are largely deployed to their variable speed features and hence influencing system dynamics. So this is created an interest in developing various different models or controlling models for DFIG induction generators in the power system analysis. So basically, DFIG induction machines are electrical machines which are fed AC currents into both the stator and the rotor windings. DFIG generators are far the most widely used type of machines in the field of wind turbines to generate the electricity. So they are having number of advantages. The primary advantages of the wind turbine is to amplify the amplitude and the frequency of the output voltage and to maintain a constant value. No matter the speed of the speed is blowing on the wind turbine rotor. Because of this, DFIG induction generators can be directly connected to the AC power network and remain synchronized at all times with the AC power network. Other advantages include controlling of the power factor and to maintain it at the unity level. So the amount of wind power integrated is large-scale electric power systems. Covers a small part of the total power system load. The rest of the power load is for the largest part covered by the conventional, thermal, nuclear and the hydropower plants. So this paper presents the modeling and the simulation analysis of the DFIG control systems. So when coming to the calculation part about the wind turbine model, here is nothing but the mechanical output power. So from where we are getting the mechanical output power? It's from the input is nothing but the wind speed. As we are getting the wind speed, the output power can be calculated by using this formula, that is called as Cp at the rate of lambda beta rho a by 2 d cube winds. That nothing but here is nothing but the mechanical power output of the turbine. Cp represents the coefficients or the constant parameters you can say, where rho represents the air density measured in kg per meter cube. A is the area of the turbine and wind B is nothing but the wind speed. Lambda is the tip speed ratio, the ratio between the first side of the input of the rotor and to the last side. And B represents the blade pitch angle, which is measured in degrees. So this is the centralized per unit value for the PM, where the performance of the coefficient depends on the wind speed. The wind speed turbine of the pitch angle and to the blades. So the power of the coefficients can be calculated through this equations. So the ratio lambda can also be called as tip speed, that is rho r by v, where rho represents speed of the turbine, r is the blade radius and v is the velocity. So these are the different analysis and calculations taken by through power coefficient versus alpha and the beta. So operating principle of the wind turbine. As you can see, this is nothing but the total operation of the wind turbine. So here is nothing but the input side, that is nothing but the turbine blades which will be rotated only through the blades given to the stator and to the rotor side of the driver plane circuitry. and then followed by this when connected to the power circuit controller. Like we're talking about is switches. Like you can use any type of switches, either MOSFET, IGBT, IGCT, SCR controlling techniques, any one different controlling techniques you can use. So here different powers also will be transferred. Like this is nothing but the power connected to the grid side and nothing but the real, and the QC represents the reactive power connected to the grid side, that is nothing but the reactive. So all the power speeds and the power data has been calculated as shown here. So PS represents the stator electrical, PR rotor, GC grid connected power, and QS reactive, and then QR rotor reactive, QC grid connected reactive. Likewise, as there is a change in the torque. So what is basically a torque?